A big issue with students on this module and a load of other modules that I teach is the maths and basic algebra. And, you know, it's no problem having a difficulty with algebra. But what I want to talk you through is why it's important and the way I deal with it. And it may be worth some of you making a note that I'm at the time in the class that I'm doing this and coming back and watching the recording again and just getting a handle. If you follow the approach that I'm going to talk you through now, it should help. I would hope it would help in just doing the maths. And the basic algebra that I'm going to talk about is the algebra you need to do this module. Okay, is basically the maths you need to do this module. If you get the hang of this algebra, you know, it makes a huge difference to how you'll do on the in the exam. You know, if you clearly understand this, it will make a difference of 15-20% in your final mark. So it is worth focusing on and practicing. And, you know, students have told me in the past, it doesn't feel right. Okay. I hope this doesn't upset you too much, but I don't care about your feelings an awful lot when it comes to this. It's not how it feels. It's factual and it's the emotion doesn't come into it. So try and get beyond doing things by gut feeling. Okay. The scientific approach is to do things on a logical basis. And, you know, it's not our natural way of working. It turns out for me, it is my natural way of working. I get into awful trouble with my wife as a result of that. But it you know, try and get in contact with wherever that logical part of you is, and try to leave feelings out of this, and try to and not get panicked by the maths either. It's one rule, two rules that you have to apply, and make sure that you're clear when you're applying it. Okay, so I'm going to obviously clear the board again, and I'll talk you through this basic bit of my basic maths. And like I say, if you get this, some of you will have this already. Some of you will be comfortable with algebra, but I would say the majority in the class, generally, it's the majority are not. And if you're thinking, well, this is because I left school sort of 10 years ago, 5 years ago, 15, 20 years ago, the students, the full-time students that have just finished leaving cert are coming into me, and they have the same issues, the same problems. So you're not exceptional in that if you do have a problem with the algebra. Okay, so we'll set you up again with a whiteboard. So the first thing that I want to say is the equal sign. Equal sign is much misunderstood. And everybody knows what it means. It means that whatever's on the left-hand side equals whatever's on the right-hand side. Okay, that's fine. We can say 5 equals 5. Now, if I change either one side, that equation is still correct as long as I make exactly the same change to the other side. Okay, so for example, I could go 5 plus 2. I've changed this one by plus 2, therefore I have to change that one by plus 2. Okay. And really that's the basis of algebra. The equal sign means whatever's here must equal there. And whatever change, in order to keep things equal, whatever change you make to one side, you must make to the other side. That really is the only rule there is in algebra. Whatever change you make to one side, you make to the other side. So, I'm just trying to think of where we're going. So, and there are two particular kinds of issues that arise. And you all are confused. Some of you will be confused between the rules you've been taught. But the rules that you've been taught are all based on this one rule. Okay, so we'll say that you have, all right, 5 plus 2 equals 7. Or we'll say 5 plus x equals 7. Okay. Now, one way of, we want to find out x in this situation. One way of leaving, we want to get x on its own here. We want to get rid of that 5. Now, how do we get rid of that 5? Well, one way of getting rid of 5 is to subtract it. And that gets rid of the 5 from that side. How do we get rid of the 5? Well, if we've subtracted 5 off here, so therefore we're going to have to subtract 5 off here. Okay. And so as a result, we end up with x equals 2. Now, you're well ahead of me. You all knew that was going to be the answer. But it's useful to do these sort of things with simple numbers first to see what's happening. And always go back. Another thing you should always do is go back to the start and see, does it work? 5 plus 2 equals 7. Yeah, that's correct. I've done it correctly. Okay, so the way we got rid of the 5 there was subtracting it off. And if we subtracted it off here, we subtracted it off there. Now, what you learn as a result of that rule is that if you have that there, when you take a number, if you're adding or subtracting two numbers, and you take one of the numbers across the equal sign, then you change the sign of the number. So that plus 5 becomes minus 5 when it's moved across the equal sign. So that's a shorthand way of saying if I subtract 5 from here, I've got to subtract 5 from here. So adding or subtracting, you move a number across the equal sign, it becomes a negative. Okay, and so x minus 3 equals 4. Well, the minus 3 goes over to there, it'll be plus 3. X equals 4 plus 3, which equals 7. Sorry, 4 plus 3 equals 7. So what I did here was I added plus 3 to that and plus 3 over there. The plus 3 and the minus 3 cancel out, and so you end up with x equals 7. Okay, and remember what I said, go back to here again. 7 minus 3 equals 4, correct. Thumbs up on that one. So adding or subtracting, when you're adding and subtracting two quantities, when the one quantity moves across the equal sign, it changes sign. That's all that happens to it. Right, so that's one half of it, adding and subtracting. Now we have to deal with multiplication and division. So 5x equals 10. Now we're multiplying two numbers here. So how do we make x be on its own here? We want to get rid of that 5. How do we get rid of that 5? Well, if we divide by 5, 5 over 5 equals 1, and it doesn't, you just have one x, you just have x on its own. I've divided by 5 there, I've got to divide by 5 there. Okay, so, and we get 2. So hold on, I should really write that down separately first. So 5x equals 10. Divided by 5, grand. Therefore, x equals 2. Of course, what you learn as the abbreviated way of doing that without going through that step is that if you're multiplying two numbers, you take the number and it goes under the line when it goes across the equal sign. You're basically cross multiplying, or in this case, you're taking the number and it goes in under the line. So therefore, if that equals that, therefore x equals 10 over 5. Okay. So if you have fractions, x over 3 equals 7. Okay, so how do you get rid of the 3? Well, you need to multiply by 3 up here. How do you get rid of this? How, you multiply by 3 there. You got to multiply by 3 there. Sorry, I'm going to 3 times x. Okay, they cancel out. So x equals 21. And what you tend to be told then is that, or what I tend to do for shortcut, a number under the line goes above the line. So if that's under the line, it goes above. So that therefore x equals 7 times 3. If you have 7x equals 14, a number above the line will end up under it. X equals 14 over 7, which equals 2. And again, like I said, go back. So x, what are we saying? That's 21. So go back here. 21 divided by 3 equals 7. Yes, correct. 7 times x equals 14. X equals 2. 7 times 2 equals 14. Correct. Now, the answers that we'll be getting in the questions that we do will not be as simple as that. Okay, there'll be 1.76 or 3.542. It's not even numbers, so you won't be as easy. It's not as easy to spot the patterns, but the pattern is there all the time. And of course, the real confusion comes in, and you will have this. So let S equals ut plus a half at squared. Now, I'm only going to work in letters, but I'm just going to use the rules we've just had. And the question I'm going to ask you is, what is u equal to? If I were to rearrange that, what is u equal to? So this is the thing I want. Okay. Now, the easiest thing to move first is this whole part here. Right? How do I get rid of that on this side? Well, I do minus a half at squared here. That means I have to do minus a half at squared here. So this becomes s minus a half at squared equals ut. Those two numbers are multiplied by each other. So therefore, if I move the t, it has to go in under the line. So s minus a half at squared divided by t equals u. Now, you might be thinking, oh, the u's on the wrong side. There's no wrong side. All I'm looking for is you to get a value on its own, okay? Now, I'm not expecting you to do this when we do. I'm expecting you to put the numbers in and rearrange things. But if you can do it this way, do it that way. But it's the same basic rules that we're using the whole time. Okay, so actually I have no timer on this, so I have no idea what part of the recording that was. But anyway, it is worth looking at that from time to time and just reminding yourself of the rules. Actually, I'll write out what I've been saying, I suppose. I'm not sure it's in your notes, but so adding or subtracting. Sorry, I shouldn't say number because it could be a letter. A quantity, I'll just say. And the big final advice, only do one step at a time. Very, very important. Closing your eyes and moving everything around all at once and hoping it's right won't work. Well, it could work. It'll work 1 in a million times. But and crossing your fingers and things like that there, yeah, there's no real room for it. So if you can remember those steps, just practice them. Keep doing them over and over and over and over and over. And when you think you've got it, keep practicing after that again. Okay. Redo calculations over and over again, even though you know them backwards. Keep doing them because it's muscle memory. It's doing the same thing again and again and again. It's how you learn to play a musical instrument. It's how you learn anything. You do it over and over until it becomes natural. I was going to say until you do it without thinking, but no, that's never correct. I remember being taught at school that you're supposed to, you do French and you shouldn't think about it. You shouldn't think about translation. You just automatically translate. And that made no sense to me at all. And now I've done some French language courses and they all say you have to translate from French, from the English. You have to translate what you want to say in English into French and then say it. You can't do it automatically. We think about everything we do without realizing we're thinking.